The other thing you should have learned in the POGL activities is how to do line drawings and how to interpret line drawings. Okay? For example, we have the compound butane, we have the chemical formula, we have the structural formula, and then a really, really shorthand way of doing it is to use a line angle drawing or just a line drawing. It's called a line angle or just a line. And to interpret this, you have to remember that you have to assume that the carbon always has 4 bonds, which it does. Okay, in these organic molecules. So you're assuming that the carbon has 4 bonds. And the shorthand is if at every end of these little lines, say here's an end point, here's a corner point, end point, at every one of these points there exists a carbon atom. Okay, so 1, 2, 3, 4, 1, 2, 3, 4 carbon atoms. And if nothing else is on it other than these little lines, then you assume that the carbon is saturated with hydrogens, okay? Unless otherwise indicated, you assume it's saturated. In this case, you've got isobutane, and so you've got, there's one of the carbons, it's saturated with 3 hydrogens. There's another carbon, it's got something else other than the hydrogens off of it, and there's the end carbon. This little line coming up is the branch. Remember, at the end of each one of these lines and at the intersection of each one of these lines is a carbon atom. So here's the 1, 2, 3, 4 carbon atoms. Each one of these carbon atoms is saturated. So this one, since it has 3 carbon-carbon bonds, the 4th bond is hydrogen. Okay, so this would have a hydrogen here, and then 3 hydrogens, 3 hydrogens, 3 hydrogens, like that. All right, and then here you see hexane, and you just see 1, 2, 3, 4, 5, 6. Those are the 6 carbons in hexane. They're all saturated with hydrogens. That means the ones in the middle of the chain have 2 hydrogens on them each, and the carbons at the end of the chains have 3 hydrogens each. Here's something, cyclohexane. Sometimes these alkanes or hydrocarbons, it can be an alkyne, or an alkene, can form ring structures in which the end carbons have swung back around and bound to each other. So this is the chemical formula for cyclohexane, and whenever it's cyclic, circled back around and bound to the end of itself, we prefix it with cyclo, and each corner there's a carbon. So there's 6 carbons here, each one is saturated, and since each carbon is connected to 2 other carbons, see there's a carbon here and a carbon here and a carbon, carbon everywhere, since each one of these carbons is bound to its neighboring carbons, that means that it only needs 2 more bonds to satisfy that it has 4 bonds. So each one of these carbons in this chain has 2 hydrogens, and you can see it here in this structural formula. All right, so you need to be familiar with that. You need to practice. And you need to practice looking at the line drawing and going all the way back to the formula, looking at the formula and doing a line drawing. And you have homework problems to practice doing that.